All right, so for today's class, we started off with this word problem that talked about the genes for collies. So we know that for each parent, the genes were black and red, and they each had 50% of it. So in class, you guys told me, looking at this Punnett square that was made, it would be a 75% chance that it would be black patches, because we saw up here in the description that if it has at least one capital B, it would turn out to be black. And that's 3 out of the 4 options, so that's 75%. But because we are such at a higher level, I want us to be able to show it in a polynomial version. And you will see this on the quiz, so let's make sure we're all on top of this. So we know that to make up one dog, that would be 100% of something. So we see that this parent is 50% the black and 50% the red. And the other parent is as well. So we're multiplying them together. So we know that can become our special products, and we square it. So if we do that in our polynomial version and we use our special products rule, it becomes the first squared, which is 0.25 BB. I'm only writing it as BB because that's what it is on the other slide, BB. This will become plus 0.5 DR. And this will become plus 0.25 RR. We know normally we'd write this as B squared, R squared. However, this is the way that they determine the genes of the collie. So if we look, we know that if it has at least one capital B, it is a black collie. So this would be it, and this would be it. If we add up the numbers in front of it, that gives us 0.75, which is their 75%. So that's how we would do a problem like that. I gave you one on the homework, so if you could replicate that, that would be great. Now we have an amphitheater, which consists of a circular stage surrounded by circular levels used for seating. So we can draw it. We know that my circles aren't going to be that great. I'm not an artist. They're not even though they should be. We know circles are even on all sides. It says that this radius of the stage is S meters, and each seating level is 1 meter in width. So that's 1, 1, and 1. So we want to find the area of the third seating area. So that means just this portion around here. We just want this shaded region. So we saw that last few classes. If we want to find the shaded region, we find the area of the total and subtract it by the missing part. So that would be, we have pi r squared for a circle. So the radius here for the total would be s plus 1 plus 1 plus 1, which is s plus 3 squared. And then we want to get rid of the part that's not shaded in, so that's s plus 2 squared. So we do pi s plus 2 squared. So our final answer is going to have pi because we have pi here, we have pi here. If we distribute it, it would remain. So we're just going to ignore the pi for now and throw it in at the end. So this part using our special products is s squared plus 6s plus 9, the pi, minus s squared plus 4s plus 4. So I'm going to look at just the polynomials and subtract inside. S squared and s squared goes away. 6x and 4x gives me 2s. 9 minus 4 gives me 5. And we can put the pi on the outside. I'm not going to make you distribute, and we would leave it like that. Now let's get into polynomial division. This is where it gets a little bit tricky, but we have to think back to our elementary days of normal division, where we try to see what we can do to get it to be what's on the inside, and then we use our opposite operation to move it down. So we're going to put the 2x squared plus 7x plus 6 on the inside. and we put x plus 2 on the outside. And we're going to think, what can I multiply 2x by? What can I multiply x by to get 2x squared? So I would multiply it by 2x. And now for normal division, we would do 2x times x and subtract that, and it'd be minus 2x squared. Now we would do 2x times 2, which becomes 4x, and we have to subtract it. We're doing the opposite sign. So that gives me 3x plus 6. Now we think, what times x gives me 3x? That would be positive 3. So we subtract 3x. 3 times 2 is 6, so we subtract 6. So this one worked out nice. Our final answer would be 2x plus 3. So that's what you would write down. These two are going to be exactly the same. So we're going to do 5x squared plus 3x minus 2 with the x plus 1 on the outside. So this becomes 5x. So subtract 5x squared, subtract 5x, and we get negative 2x minus 2. How do I get x to become negative 2x? I multiply it by negative 2. Once again, negative 2 times x gives me the negative 2x, but I have to use my opposite operation. So we add 2x. Negative 2 times 1 is negative 2. We have to add 2 because it's the same thing as saying minus negative 2. That gives us the plus. So I write my final answer as 5x minus 2. Next one, same thing. Square root of 6x squared plus 7x minus 20. 2x plus 5. So this gives me 3x minus 6x squared then, because we do 3x times 2x is 6x, subtract it. 3x times 5 gives me minus 15x. So we get negative 8x minus 20. To get 2x to be 8x, we'd multiply it by negative 4. So this gives me plus 8x, because we're doing minus the negative. Negative 4 times 5 is negative 20, so minus the negative gives me a plus. And my final answer would be 3x minus 4. Now we do something like this. We're going to get a remainder. So 2x squared minus 11x minus 20. 2x plus 3. So we multiply it by x. So minus 2x squared minus 3x. So the positive becomes the negative now. This becomes minus 14x minus 20. So to get negative 14x, I multiply 2x by minus 7. All right, so this will now become plus 14x. This will become plus 21. And we're left with a 1. And you know after the constant term, there's nothing we can do. So our remainder is 1. So we would write this as x minus 7 plus 1 over 2x plus 3. And the reason we do this is because when we multiply by 2x plus 3, the denominator and numerator obviously go away, and we're left with just 1. So let's check our answer. 2x plus 3 times x minus 7 gives me 2x squared minus 14x plus 3x minus 21. So 2x squared minus 11x minus 21. But then you're like, wait, but we want minus 20. That's where this comes in. 2x plus 3 times 1 over 2x plus 3. These cancel out, and we're left with plus 1. So we add 1, and we get 2x squared minus 11x minus 20, which is what we wanted. Bam, bam, this is correct. So that's how you would check your answer. Now let's take a look at something like this, another remainder problem. 2x to the third plus 4x squared plus 5x minus 1. And you can pause these at any time to retry them if you want, or see if you know what's going on. So we multiply x by 2x squared to get 3x. So minus, I mean to get 2x to the third, sorry. Minus 2x to the third plus 6x squared, because we have negative 3 times 2 is negative 6, but we do opposite operations. I'll say that like 20 times on this video. 10x squared plus 5x minus 1. Remember, we always carry down everything else that we have. X to become 10x squared, it multiply by 10x. So minus 10x squared plus 30x. 10x times negative 3. So we get 35x minus 1. So we're now multiplying by 35 to get 35x. This is 105. So our remainder is 104. So my final answer would be 2x squared plus 10x plus 35 plus 104 over x minus 3. We always do the 1 out here. If you want to check, you can. It takes some time. I totally suggest it. If you do get a remainder that looks a little crazy, to check it just in case you did something a little wrong. And there's a lot of places to make errors here. I can try the first one with you just to see how we're doing. I want you to try this one. We didn't do this one in class. Try it. Now let's see if you got this right. So the square root of 2x cubed minus 3x squared plus 4x plus 5. And the outside's x plus 2. So we multiply by 2x squared. So minus 2x to the third minus 4x squared. So negative 7x squared plus 4x plus 5 minus 7x gives me the plus 7x squared, gives me the plus 14x. So I get 18x plus 5, so plus 18. So this would be minus 18x. This would give me minus 36. So we have a remainder of negative 31. So I would write this as 2x squared minus 7x plus 18 plus negative 31 over x plus 2. And I can check because that seems a little bit weird. X plus 2 times 2x squared minus 7x plus 18 gives me 2x to the third minus 14x squared plus 18x plus 4x squared minus 14x plus 36. So 2x to the third minus 10x squared. Did I multiply wrong? Yes, this should be minus 7x squared. See? We can make mistakes. So this should be minus 3x squared, which is what we wanted, plus 4x plus 36. Now when we subtract the 31, we get the 2x to the third minus 3x squared plus 4x plus 5. So as you can tell, sometimes you might do the foiling incorrect, which would think you did it wrong. But just double check everything and you should be good. So for the next problem, this one's a little bit different because now we're missing a part of the polynomial. We're missing plus x. So you can always do plus 0x, or you just have to remember you're going to have to bring it down. So this would be 2x on the outside minus 5, square root of 2x to the third minus 9x squared plus 15. So this becomes x squared, so minus 2x to the third, plus 5x squared, negative 4x squared plus 15. So minus 2x plus 10x. Oh, this would be plus 10x, so this is minus 10x. So negative 10x plus 15. So we multiply this by negative 5, so plus 10x minus 25 gives me negative 10. So my final answer will be x squared minus 2x minus 5 plus negative 10 over 2x minus 5. So I'm getting used to writing plus a negative because sometimes we have two terms in our remainder, and if we just do a minus that, it becomes incorrect. So always get used to writing plus a minus sign. I know it's a little bit weird, but it helps to make sure you're writing it correctly. We also have to be careful that we're doing the correct sign. As you can tell, I almost accidentally wrote the wrong side. So it's making sure we write that opposite sign. Maybe you have to take a little bit more time, and I will give you some time on the quiz because I know this is a little bit more in depth than other things. It takes some time to make sure you're understanding where you're going right and wrong. All right, let's try the one on top. I'll do it over here. X to the fourth plus 3x squared minus 6, x squared plus x. So this becomes x squared. We subtract x to the fourth, subtract x to the third. And as we see, there's no x to the third, so we just carry it down, carry the rest down. Now we have to subtract an x, add an x squared. So this becomes 4x squared minus 6 plus a 4 minus a 4x. And we know there's nothing else you can do after we have this constant. So this will be our remainder. So this will become x squared minus x plus 4 plus negative 4x minus 6 over x squared plus x. And once again, I told you this is why, because if I did a minus 4x minus 6, that is incorrect. You would have to take the minus sign out of everything. You might as well just do the plus, whatever it is, so you're not making a mistake there. Finally, the last one on here, we'll do the square root of 6x to the third minus 8x plus 5. And I'm saying the square root, just ignore me when I say that. I just mean the division symbol. They look exactly the same. We're not square rooting anything. That was a mistake that I said that. So to go from 2x to 6x to the third, we multiply by 3x squared. This will become plus 12x squared. 12x squared minus 8x plus 5. We multiply plus 6x. We multiply, that becomes negative 24x. We add 24x. This is 16x plus 5. To get to 16x, we add 8. So we have to do 8 times 2, which is 16x. 8 times negative 4 is negative 32, so we're adding 32. So our remainder will be 37. So our answer will be 3x squared plus 6x plus 8 plus 37 over 2x minus 4. And we can check that. 3x squared plus 6x plus 8 times 2x minus 4 gives me 6x to the third minus 12x squared plus 12x squared minus 24x plus 16x minus 32. These cancel out. We get 6x to the third minus 8x. The negative 32 and the positive 37 give me the plus 5 like I wanted. So this is our correct answer. Finally, I want you to use this one to complete the first question, the first multivariable question on the homework. This one's a little bit of a step up. So if we take a look, I suggest always rewriting in order from biggest first variable exponent to least. You don't have to do this. You really don't have to, but I think it just makes it easier to see what we should be multiplying by to cancel things out. And like I told you in class, when we have two variables, I'm never going to make a remainder because that's just way too much. You'll never know when to stop. You'll never know what's going on. So we'll rewrite these. And we'll get x to the fourth y plus, I'm going to do the x to the third y squared because yes, these are both x to the third, but this one's a bigger degree. Does it matter? No, but that's my preference. Plus x squared y squared. And I cross them out to make sure I have them all. Xy to the third plus xy. Good. And I'm dividing it by x squared plus y. So to get x to the fourth y, from x squared, we're multiplying it by x squared y. So this is minus x to the fourth y. X squared y times y is x squared y squared. So minus x squared y squared. And we find which one that lines up with. We're not going to just throw it in there. See where it lines up with. X to the third y squared plus x to the third plus xy to the third plus xy. Just carry everything down so we're able to see what's left. All right, to get to this one, we multiply by x, y squared. So minus x to the third y squared. X times xy squared times y is xy to the third. Bam. And we're left with x to the third plus xy. So we add x to this to make this x to the third. X times y is xy. And we know we have our right answer because it all worked out. So we're going to work with the multivariables a little bit more. The last problem on the homework is a little bit of a challenge when I want you to try that one. If you don't get it right, if you're a little bit lost, that's okay. We're going to go over something like that next class. So email me if you have any questions.